Hi, I'm Daniel Gizinski, and I'm going to be talking to you today about SQL injection and sanitizing database input. So what's the problem? Databases are vulnerable to malicious input from users in a variety of ways, and there will always be users that, for a multitude of reasons, will look to exploit things, whether for monetary gain, intent to cause damage, seeking confidential information. There's a whole set of reasons. So how exactly are they vulnerable? They're vulnerable to a technique known as SQL injection. SQL injection is the process of using input fields as a doorway to input malicious code. If the database does not filter or sanitize these inputs, a user can accomplish almost anything by using SQL injection. I'm going to walk through an example of blind injection, which assumes no prior knowledge of the database, the schema, or anything related to it. So the first step is going to be to check and see if input is being passed literally. So what we're going to do is we're going to go ahead and find a input field, and let's say in this example that it is a password reset field. We're going to input a single quote into the email address field, and we're going to get one of two possible things. Like we might get a some sort of warning, but there's a variety of different ways that it can be handled. What we're looking for is a 500 error or a server failure, which will suggest that the broken input is actually being parsed literally. So if we get this, we can kind of assume that the surrounding PHP code looks something like the following. Now, we don't have a valid email address to put into the red text field, which is the input box, and so we're going to put in something like the following, where the first field is irrelevant, and then we OR it with a tautology. Since the second part will always evaluate to true, the whole thing evaluates to true. How this will be handled will vary, but in a password reset field, we can expect something like the following, where it lets us know that our login information has been mailed to some random person from the list. Now, this only gives us a email address. It doesn't actually give us a way to log into the database, so you might be saying that this doesn't seem like a very glaring vulnerability, but we can actually use this information to discover quite a few other things. The next step is going to be to determine the schema of the database. This is known as schema field mapping. We can use similar techniques to the ones already demonstrated to determine table names. You might guess that since there's a field for email, there's also a table for passwords. So we'll input something like the following, where the email equals this and find the count from the password table. Now, obviously we don't care about the actual count from the password table. This is just used to let us know whether or not password is a valid table. If this fails, we know that the password table isn't known. If this comes back with some integer, we know that there is a password table, and we can use this information to exploit that. We can use this to create new users, change emails, drop tables, and lots of other different things that probably the owner of the database doesn't want done. An example of something we could do that's pretty malicious would be something like the following. Into the input field, we can put in drop table members. Put a semicolon in the line and then a pair of slashes to comment out anything else surrounding it, and we've dropped the member table. Boom, gone. Lost all that data. You can see where this would be a big risk to a company that did a lot of business if you just lost every single customer's data that you've used. Another example is we can use this method to get into the system. You're going to input something like this, where you're going to update some field in the table and set the email address to your own email address. Now, when you do a password reset request, this email will go. The email with the login information will go to you instead of the intended user. So I'm going to talk a little bit about preventing SQL injection. A logical first step in preventing injection is going to be to identify and strip potentially malicious input. This includes things like JavaScript, HTML tags, comments that span multiple lines. Those are generally not things that you want in a user to be able to put into your code. A good principle is to allow good characters rather than deny bad characters. So, allowing somebody to choose between characters and numbers is much easier than trying to deny certain characters. Another helpful technique is known as typecasting. This is basically verifying data input to a field matches what we expect it to be. A phone number shouldn't be getting past a string. If you get a string, you can go ahead and deny that. This also helps prevent typos. If somebody accidentally puts an A instead of a 3, you're going to get an error back rather than just accepting that as their phone number. It's also helpful to limit permissions. For instance, permissions are given to even non-users, such as login and send me password. You want to minimize permissions given to non-users and actually minimize permissions given to regular users as well, so that somebody looking to maliciously attack the database has less of an opportunity to modify things. A couple problems are not everyone is actually hacking, and being overzealous sanitizing your inputs can make things tough. For instance, if you try and filter out a single quote, someone with the last name O'Kelly is probably not going to be very happy with you, and they're going to have a tough time doing this. And there will always be a way around, no matter what you do. So it is important to look for other methods to protect your database.